Hello everyone. Today we are going to learn about electrochemical corrosion. One of the type of corrosion. There exists broadly two types of corrosions. Dry corrosion or chemical corrosion, wet corrosion or electrochemical corrosion. In this today's video lecture, we'll be focusing on what is electrochemical corrosion, conditions required for electrochemical corrosion, mechanism of electrochemical corrosion, types of electrochemical corrosion. What is electrochemical corrosion? Before that, we will be understanding what do we mean by chemical corrosion. We already discussed that there exist two kinds of corrosion, chemical corrosion, electrochemical corrosion. Due to the direct attack of chemicals, environmental gases onto the surface of metal, in absence of moisture, if that take place, corrosion take place, that is called as chemical corrosion. Here comes what do you mean by electrochemical corrosion? So in the name only we are having the meaning due to the existence of electrochemical cell. During this electrochemical corrosion, what is existing? Electrochemical cells are existing. So what do you mean by electrochemical cells? Electrochemical cell is a physical entity consisting of anode and cathode, capable to convert chemical energy to electrical energy and electrical energy to chemical energy. So this definition, electrochemical cell, is obviously related to electrochemistry. How do we can connect this to corrosion? Yes, of course, we can connect this corrosion to electrochemistry because corrosion occurs through simultaneous oxidation and reduction reaction in electrochemical corrosion. So, what is electrochemical corrosion? This is a type of corrosion which occurs under wet or moisture conditions and is more common than dry corrosion. Hence, it is also known as wet corrosion process. Okay. Then when it can occur? So when it can occur? So what is the reason for the formation of this electrochemical corrosion? So when a metal is in contact with a conducting liquid, or when a metal is exposed to different reactive conditions, this type of electrochemical corrosion can occur. That means to happen this electrochemical corrosion, metal should be in contact with a conducting liquid, which is acting as electrolyte, and metal has to expose to different reactive conditions within a solution. So best example for this electrochemical corrosion is we all common know that is rusting of iron. Okay. Then, so what are the conditions for electrochemical corrosion? Here are the conditions for electrochemical corrosion. There must be the formation of anodic and cathodic regions. Electrode potential between the electrodes must be differed a lot. A metal path must connect the anode and cathode. Conducting liquid should be present between the two electrodes. These are the four conditions required for the electrochemical corrosion. So if we come to the mechanism of electrochemical corrosion. So electrochemical corrosion mechanism. This mechanism, so since it is electrochemical reaction where simultaneous oxidation and reduction take place. That means one species or one part of the metal would undergo into oxidation and become anode, and the other part of the metal will undergo into reduction and becomes cathode. So electrochemical corrosion mechanism, in the electrochemical corrosion mechanism, we could see two type of reactions. At anode, we could notice anodic reactions. We all know that at anode, generally oxidation occurs. Oxidation means loss of electrons. So whatever part of a metal is losing electrons, that is undergoing into corrosion. Then apart from that, simultaneously, another reaction will take place, that is cathodic reaction. Anodic reactions in this electrochemical corrosion mechanism is common, but the cathodic reaction mechanism would get vary depending upon the medium with which the metal is in contact, depending upon the nature of the electrolyte with which the metal is in contact. If the metal is in contact with a acidic environment, the mechanism would proceed through the evolution of hydrogen. If the metal is in contact with a basic or a neutral environment, the mechanism would follow through the absorption of oxygen. So anodic reaction at anode, anodic reaction mechanism. At anode, obviously, oxidation occurs and metal losses electrons. The metal part where the loss of electrons take place, corrosion occurs over there. And readily those electrons and the metal cations will be transported to the cathodic area. So at the cathode, as I discussed earlier, depending upon the electrolyte nature, if the electrolyte is acidic in nature, the mechanism will be followed through the evolution of hydrogen. If so when this evolution of hydrogen mechanism take place, if that is in contact with a acidic medium, okay, then if the metal is in contact with a basic or a neutral medium, the reaction mechanism will proceed through the absorption of oxygen. So let me see the cathodic reaction mechanism through the evolution of hydrogen. So here you could see the here you could see the iron, okay, iron metal rod, where here a large anode is there. This part, total part, we are saying it as anode, okay, anodic area. Then this small part or surface of the metal, we have considered it as cathode, okay. Then it is exposed to acidic environment, H2SO4. Obviously, H2SO4 will give H plus ions. So that there is a release of H plus ions because H2SO4, if you are taken, that will release to H plus plus SO4 2 minus. So we already discussed at anode, iron is undergoing into oxidation, if that is getting converted as Fe2 plus, and also it is releasing 2 electrons. Okay, so those 2 electrons which were formed at anode region along with these metal cations will migrate to this cathode region, and at cathode, what are there? 2 H plus ions are there. Those H plus ions absorb the electrons, or they gain the electrons and undergoes into reduction to evolute hydrogen gas. So this is the mechanism happens when a metal is in contact with acidic environment. When a metal is in contact with acidic environment, the metal cations and electrons will be sent to the electrolyte medium. In the electrolyte, obviously, acidic electrolyte is there, which is having more number of H plus ions. Those H plus ions are electron deficient, so they gain electrons and undergoes into reduction, then evolutes hydrogen gas. So thereby you could see the corrosion of this anodic region due to the loss of electrons and corrosion product formation at the parenthesis or at a cathodic region. Okay, so here you need to keep in mind, though the anode is undergoing into corrosion, the corrosion products are observed at cathode because these metal cations and electrons are easily can migrate to the cathodic region due to their left sides. And they could result in the formation of corrosion byproduct. There may be the formation of FeSO4 or Fe2SO4 like that. Okay. So corrosion ferrous sulfate or ferric sulfates will get formed along with the uh, like evolution of hydrogen at cathode. So this is about the cathodic reaction mechanism through the evolution of hydrogen. Then if we come to the other part, that is the cathodic reaction mechanism through the absorption of oxygen. For this, here I am considering iron metal as usual. Okay. So where cathodic area, large cathodic area is there. Okay. Here, this part of the metal is being converted as anode because here some damage been happened. So wherever stress happens, the stressed part will become anode. So this stress part, anode, at this part, what is happening? Iron grains are undergoing into oxidation, Fe2 plus, and 2 electrons, that is releasing 2 electrons. So those 2 electrons will be sent to whom? Here, absorption. So here, what medium is there? Here, the medium is neutral medium or alkaline medium. So in the neutral medium or like water, in the water, oxygen is there. Oxygen, generally water absorbs oxygen. That oxygen and in presence of water gains electrons and forms what? Hydroxide ions. Those with that the mechanism would not get stopped. That formed hydroxide ions readily get interact with ferrous ions and forms ferrous hydroxides. With that itself only the reaction would not get stopped. Ferrous hydroxides in turn interact with water, and at last they will be leading to the formation of rust over there in the